Well, I'm Adam.
I'm Paperclippe.
And this is our web series called Science. Just to stress, we don't really have any kind of science background, so to speak, but we read a lot.
Mm-hmm. Science is for everybody, especially science with an exclamation point. I run the science section of a bookstore. I guess that makes me an expert.
The closest thing to it that we can get a hold of.
English major dropout, now works in a bookstore, reads a lot of science.
Well, I guess the electrician does some sciencey things.
You have the capacity to blow up stuff.
We do. I mean, we talk about electrons and stuff. We don't have to, but we do just because we like to be smart guys. This is basically, we're going to take some complex science and try to put it in a format that, everybody can understand.
Yeah, it's like Bill Nye the Science Guy with a budget of $0.
Yeah, we got $0.
$0. Anyway, since this is the beginning of the show, we thought we would talk about the end of the universe.
Yeah, that should be sweet, huh?
Yeah, in a Whovian sort of turn of events.
Yeah, I guess. Probably won't be around to see it, theoretically, but yeah, you never know. If their math is really wrong.
If their math is really wrong, we can see it tomorrow.
When we see it, though. We wouldn't, technically see anything if the universe ended.
That's true.
But, well, let's talk about that then. The universe ending, what is the current theory?
Well, there had been a couple of theories. Just to start at the very beginning, there was the idea of the steady-state universe, which was that the universe was constant, never changed. It was tied into a lot of religious philosophy, but it wasn't necessarily we think the universe is constant because God. In fact, a lot of atheist scientists believed it because they didn't want to believe in a beginning and an end. But that was exactly that. The universe is never changing. Matter is basically self-replicating. Nothing can be created or destroyed to such an extent that the universe itself cannot be created or destroyed. We basically now know without any shadow of a doubt that is completely and utterly untrue because of images from satellites we have that have mapped heat signatures from the beginning of the universe. So, if nothing else, we know that there is a beginning.
So are you talking about cosmic microwave background radiation?
I am exactly talking about cosmic microwave background radiation. Yeah, it's basically a picture of the heat of the universe from, I believe it is 300,000 years ago, or after the beginning of the universe. That is as far back as we can see.
Okay.
We cannot see any older than that. It's got slight variations in the heat, which tells us that that's where galaxies and things start to form. But that's the beginning. We know there was a beginning, period, full stop.
And basically, they figured that out by saying, okay, assuming a Big Bang.
Mm-hmm.
The universe had to be X temperature. It had to be so hot to keep the atoms from, bonding with each other.
Exactly.
Essentially. So over however many billions of years, it would have cooled down to whatever they think the temperature is now, and when they took their measurements, it ended up being, around what they thought. And it's funny because there were people looking for this, using their radio telescopes or whatever, and then these other guys were like, hey, there's something wrong with our telescopes.
Working for a phone company.
Yeah, oh man, our thing's all messed up. We can't figure out what's wrong. And they're like, oh, we think it's this. Oh yeah, that's probably about it. And then the guys who found it by mistake, who weren't even looking for it, got the Nobel Prize instead of the guys who did all the hard work, all the math, and then oh yeah, we need to find this, and then these other guys found it by accident.
Right. No, it's basically the Nobel Committee was just these guys found it first.
Oh, right. Even though they didn't know what it was.
They had no idea. They thought it was pigeon poop.
Yeah, they're like,
and then they thought it was
gonna
cities.
Clean the fucking dish again.
They did. They went and swept the dish about 100 times before they were like, maybe this is the universe. And it was.
Yeah, well, but yeah, so why were we talking about that?
Because we were talking about the 3 options for the universe's end.
Exactly.
The second one was what is now familiarly known as the Big Crunch point. If you haven't, it's the exact opposite of the Big Bang. They thought for a while that the universe was expanding and expanding and expanding, and then it would suck itself back in because of the mass of the universe. And the gravity would just pull itself back together.
And then it would smash into a singularity and then blow up.
Or just cease to exist. Like, they thought, if there was so much mass in the universe, if lambda, if a lambda was greater than a certain thing, the universe would keep expanding. If it was smaller than a certain thing.
I thought if omega is 1, then everything evens out.
Everything evens out,
right.
Yeah.
And lambda, they haven't... Lambda, I think Einstein just kind of made it up. He's
that was the cosmological constant. Now they're saying this is what we believe now.
Okay.
The universe is not going to Big Crunch. It is not going to antithesis the Big Bang. It's just going to keep expanding and expanding. There's not enough mass in the universe, even including all the dark matter that we assume is out there. There's some force that's pushing the universe apart, and that's lambda. And it's so big that eventually, first physical objects will get farther and farther away.
Right.
And then, atoms will start to get bigger and bigger. Basically, they'll be
bigger by, less dense?
Less dense, yes. Everything becomes less and less dense. Everything becomes colder and colder because the farther away it gets, the slower it moves, and eventually it will basically just slow to a stop.
Right.
It'll keep expanding after that. It's called the Big Rip, and it's actually Big R.I.P., It's not going to rip apart. It's the big rest in peace. There's a lot of things. I mean, Michio Kaku, if you've ever watched the Science Channel, he's the awesome Asian guy with the white hair and the fabulous voice. He talks about, life adapting to this, which I think is really, really cool, in that we'll all just become sort of electric signals sending thoughts back and forth over space. And it won't seem like it's taking an eternity or an effective eternity because we're so massive and we're so spread apart, and so it'll seem like it's taking a normal amount of time. But basically, at some point, even if we do achieve that sort of life, if you can even call it that, eventually it'll be too far apart and everything will just kind of end. It'll be absolute zero.
Assuming this theory is correct, how long do we have?
A very, very long time. Well, the sun is going to explode and destroy Earth, whether or not we're still here, in 5 billion years. Yeah. The universe will take significantly longer than that. Basically, there's no point in worrying about it. We're all good.
Well, there is an asteroid that I think in 50 years might hit Earth, so...
Then we need to get on Mars very quickly.
Well, there's a guy, I don't know who it is, I was talking to my buddy over the weekend, who wants to start colonizing Mars. He wants to send robots to start building shit, and then send a handful of people to see how it goes, and then he just keeps sending people, one-way trips or whatever.
They're actually looking for husband and wife teams to go to Mars,
no
return. This is a one-way trip, tickets. You pick somebody you love and you go.
Just send Bruce Willis up there.
Tell you what,
with Steven Tyler and
great soundtrack.
A few billion years, that should be fine.
We'll be all right.
Yeah.
I mean, it's not like you had a choice.
Right. Yeah, that's true. Even if we didn't manage to live that long, it's really not. Well, actually, that far along, assuming we're still around, maybe we do have a choice at that point.
That's what I was just going to say. Michio Kaku, again, I was reading a couple of his books, and he talks about different stages of civilization. Right now, we're a stage 0 civilization because we cannot even effectively harness the power of our own planet.
Right, we're still fucking around.
Exactly. But a stage 3 civilization can harness powers outside of their own galaxy. But you would have to be able to harness the power of a black hole to be able to try and this is assuming parallel worlds exist, this is assuming many, many things, but there is a certain level of energy that we have identified that could theoretically rip apart the fabric of space and time itself, because space-time is a physical object for all intents and purposes, and we know the amount of energy you would need to break it down. So if you could break down the fabric of space-time and escape, maybe you could survive the end of the universe.
Gigawatts?
It's, something like that. You gotta go 88 miles an hour, and you're gonna need a seriously old DeLorean.
Anyway, thanks for watching. Once again, I'm Adam.
I'm Paperclippe.
Stick with us. Check out the rest of the shows on the Sinister Dream Internet Television channel. Check out Nevermore the series. Check out all the other cool stuff that people are doing online. And, maybe you can do some reading of your own. Give us some suggestions for things you'd like us to talk about. Maybe we could try to explain something that you find difficult to understand. I don't know.
Yeah, leave a thing in the comments. We probably won't read most of the comments because this is YouTube.
Yeah, this is the internet, and we don't. Who has time for that? Ain't nobody got time for that.
Ain't nobody got time for that.
So, thanks again for watching, and check us out next time.
There's always time for science.
There is always time for science.
Science.